Hello, Matt Davis here with more homework quiz help. This one is for section 11.1. Suppose that we're testing the claims H0 is that mu1 equals mu2, H1 is that mu1 does not equal mu2, and our sample of size 26 produces an average distance, d bar, of 7.832, and the standard deviation of our differences, S sub d, is 35.822, and they want us to calculate the p-value for the hypothesis test and round that to 4 decimal places. Well, before we get started with any of that, in the interest of giving help rather than answers, we're going to change that n equals 26 to an n equals 28, just to mix that up a little bit. All right, and then the other thing is you can't really calculate a p-value without a test stat, so we'll start out there. So for our test statistic, we want t equals d bar divided by s sub d divided by the square root of our sample size. So we actually have all that information and can just plug it in. D bar is 7.832. Our S sub D is 35.822. We divide that by the square root of our sample size, which was now changed to 28. And we go to the calculator and see what we get for that. It's a little less tricky than normal. We only need parentheses around the bottom, not the top. So let's go see what that looks like. So we can just put our 7.832, only one number in the numerator, so no need for parentheses. They won't hurt if you put them, but you don't need them. In the denominator, make sure you start with the open parenthesis like I did. You can see it in red there. And then 35.822 for our S. Divide that by the square root of our sample size, which is 28. And the parenthesis for the square root, and the parenthesis for the denominator, press enter, and that's our test stat. So 1.156, but the 6 is followed by a 9, so we'll round up and have 1.157. Let's go back and write that down. 1.157. So there's our test stat, which we always round those to 3 decimal places. Now that we have that, we can move on to what they actually asked us for, which is the p-value. So let's draw a quick sketch. It's a t-curve, so those are bell-shaped. T-curves have a df. df is 1 less than the sample size. If our sample size is 28, the df would be 27. These curves are symmetric with a mean of 0, so we'll put 0 in the center. We put our test stat on, 1.157. And then this is a two-tailed test because of the does not equal. And for two-tailed tests, you put the mirror image of your test stat on too, so negative 1.157. And when we go to do our p-value, we want to do the area to the right of our test stat here, but we also want this area over here as well. So it's the total of those two outside tails. But because of the symmetry, we can just find this area on the right and double it. So our p-value would be not that area on the right, but 2 times that area on the right. This is a t curve, t test stat, so we'll use t CDF, and we're going to do this area on the right is what we're going to focus on for the calculator. So the left boundary of that green area is 1.157. The right boundary is infinity, and we're working with 27 degrees of freedom. And I'm going to just go ahead and, let me show you that one actually. So when we go to the calculator, make sure you do the 2 times first to get the doubling in there, and then do your distribution menu. So second distribution, TCDF down here in row 6 for me. And then I want my left boundary, which was the 1.157. Right boundary, there isn't one, so that means we're using infinity or alpha I. The number of degrees of freedom is 1 less than the sample size, so that would be 27. And I get 0.2574. So 0.2574 for our p-value. So there's the answer to the question, rounded to 4 decimal places. So that's the piece we want. Things to watch out for. Make sure you're doubling because it's a two-tailed test. Make sure when you computed your test statistic that you remembered that you need parentheses around the bottom. Otherwise, it's going to really throw off your test stat. And of course, if your test stat is thrown off, your p-value will be as well. Make sure that you have infinity stored in I. If you don't have that, that's always problematic. So anyway, there you go. Hopefully somewhere in there you saw the spot that it went wrong for you. Good luck for you as you head back to the quiz.